Assalamualaikum warahmatullahi wabarakatuh. I want to give you some information about COVID-19 infographic. How is the current condition of the COVID victims today? In this COVID pandemic today, many victims passed away, which mostly are doctor and paramedic experts. Their expertise and experiences are very crucial in this situation. How to solve this problem? In order to solve this, we need to make the electronic medical record or EMR to collect their knowledge, but that have some difficulties to spare time for documenting this EMR. Even if it's documented, that consultation between doctors and paramedic experts with patients are not that optimum. In order to solve this problem, I would like to discuss more in our paper entitled Evaluating the BPPT Medical Speech Corpus for an ASR Medical Report Transcription System. My name is Elvira Nurfadila. This research is joint research funded by LPDP. BPPT has been collaborated with Solusi 247 and Harapan Kita National Heart and Vascular Hospital to develop ASR medical record. I would like to outline of my presentation with 4 main points, such as first, introduction, second, methodology, third, result and discussion, and the last is conclusion. Let's begin in the introduction. In this introduction, I would like to introduce the milestone about some research conducted by BPPT to ASR. It began when ILVC, which means IGOS Linux voice command, developed into Lisan, Linux with Lisan or oral. And at the end, the product got the patent name Prisala for automatic meeting minutes system in 2010. From 2017 until 2019, the speech-to-speech translation was developed in web-based and mobile. In 2019, the cooperation agreement between BPPT with Solusi 247 was agreed. Lastly, from 2020 until now, the joint research funded by LPDP among BPPT, Solusi 247, and Harapan Kita National Heart and Vascular Hospital to develop a medical speech corpus is being collaborated. Moreover, this slide will explain about the background of research related to medical ASR for EMR. About 2,000 hospitals and 9,000 health cares have been built in Indonesia until 2019. Therefore, automatic speech recognition for medical dictation and application system of electronic medical report have been segmented market because of 3 factors. First is competitiveness, legal review, and economical review. This slide will specifically talk some related work to this paper. In 1990, ASR was introduced in the hospitals. 1 decade later, the enthusiastic in implementing ASR in medic decreased because user expectations have not been fully achieved, but effort to improve it have been continuously carried out. From 2008, research of Indonesia ASR in the general domain until the present. And 2030, BPPT developed General Speech Corpus KDW BPPT 2013. The last related work in 2018, Medisco has developed medical speech corpus with 700 medical terms, and the total duration was 10 hours. Let's move on to the methodology. In this slide, I would like to present about BPPT medical corpus specification. We have already recorded 100 speakers with medical education background. The total duration of the corpus approximately 81.68 hours. The resulting transcript consists of 600 utterance. There were 2,746 items of word pronunciation of medical term. In this recording stage, I will present some stages we did, such as first of all, a transcript preparation, which is made to introduce medical term. Another stage is respondent selection, where 100 respondents were chosen. Next is the recording mechanism, which are divided into three processes, such as providing respondent to ensure the level of accuracy of the speech data, monitoring by phonemical expert, and guiding the respondent to read thoroughly. Finally, the post-recording is to re-listen all the recording audio file by editing, ensuring no more noise, and ensuring the recording file are equal and match to the number of uterine transcript. This is a documented example when the recording process began. A speaker was accompanied by an operator who is also phonemical expert. This recording process uses sound interface, which can be used for a mixer to control mix gain level, headphone level, and monitoring level. These are some modeling steps to build ASR model using PyChain. If we see number one, wave data are divided data into three parts, such as training data, verified data, and experimental data. The second number, wave data, are processed through CALDI by using MFCC feature, and then the feature normalized using CMVN technique. Next, the transcript and monolingual corpus data are processed to obtain language model and word list. Transcription data, language model, and lexical process it using CALDI to produce HCLG graph. Using the default DNR architecture from PyChain, training is carried out to get a DNN model utilizing the feature of data training and data verification that have been prepared in step 2. This resulting model is then tested using test data to choose the best model by looking at the word error rate. We have two figures. In figure 1, this is the scenario for evaluating BPPT medical speech corpus. First of all, we prepare 3 types of corpus groups for the training for automatic speech recognition. And then we build this 3 ASR model using PyChain. After all ASR model had been successfully created, we prepare a test corpus spoken by 5 speakers. Finally, we tested ASR model using the test corpus and measure the word error rate. In figure 2, this is the flow of ASR model performance measurement with WER. At the beginning of the testing process, a feature extraction process is carried out from the test data. The feature are used as input for posterior generation. Each ASR model is used to process the previous extraction feature to generate the posterior value. They code the posterior value using CALDI tools to produce text transcription. The text transcription result were then compared with the reference text transcription to calculate the WER or WER value. Table 1 show the WER measurement result for all models after the training process as described in the previous chapter. Percentage of training data is 92.5%, verified data in 2.5%, and experimental data 5%. Based on the WER value, 5.74 and 3.40 and then 3.70, the resultant model are considered as good models. This model is proven to recognize the same sentence as the training data, so that we can propose this three model to be the basic for evaluating the ASR model at the next stage. The second stage of our testing is to evaluate the ASR to find out which ASR was best at the recognition speech from the test data we prepare. We prepare a test corpus spoken by 5 speakers. The test corpus consists of 100 utterances created by paraphrasing the sentence in the training data. The test corpus include medical terms. The result from the medical speech corpus show better result than general speech corpus. Thus, it can be concluded that the evaluated medical speech corpus did contain medical related matter. However, the result of the combined speech corpus show the best result. This indicates that our medical speech corpus can be enhanced by adding more varied sentence. These slides show the comparison of original utterance from the transcript, which was compared to the decoding result with a model using BPPT, General Speech Corpus, BPPT, Medical Speech Corpus, and BPPT, Combined Speech Corpus. In the model for General Speech Corpus, this model was incorrectly recognized the word memiliki or having to be ini or this, and then word dalam or in to be dan and. While based on the BPPT medical speech corpus, this corpus was incorrectly recognized the word vitamin to be visi, and then word dalam to be dan. And at the end, BPPT as a combined speech corpus can recognize all words without any incorrect word. In this conclusion, I would like to conclude some points from this paper, such as present some experiment and the result of the quality evaluation of BPPT medical speech corpus, and then 3 speech corpus model and speech corpus group carried out testing experimentation, which the combined speech corpus show better accuracy result than others. And the final point is the BPPT medical speech corpus is an acceptable corpus for creating ASR model that can be further enhanced by adding more varied utterance. Before I end this presentation, let me give my best gratitude to LPDP who funded the publication of this paper, and also to Solusi 247 and Harapan Kita National Heart and Vascular Hospital who support us to prepare the transcript and recording process. That's all my presentation. Thank you very much for your attention. If you have a question, please.